This lesson is the basis for most everything LTM. It defines pools and virtual servers, shows how traffic flows through the system, describes the load balancing options, and has labs to test it all. Virtual servers and pools are the foundation of the LTM load balancing system. Virtual servers are the only means of using the intelligence of the LTM to process traffic. This lesson is the key to the entire course. Creation of pools and virtual servers are the foundation of almost every feature of the Big IP. The labs allow you to create these objects, use them, and then the lab drives them to statistics pages to see how you can monitor traffic flow through the Big IP. Nodes are defined as just an IP address. A pool member consists of a node and a port, which is basically an IP address and a port. With the exception of apology servers, all pool members should host the same content. They do not have to be listening on the same port. They can be on the same IP address and a different port. Clients generally do not need, and admins don't want, to be able to reach pool members directly. Pool members often have RFC 1918 addresses or private IP addresses. Virtual servers are the primary mechanism the Big IP system uses to process and track traffic. Each content site that the Big IP system manages must be associated with at least one virtual server. Like pools, virtual servers include a name, an IP address, and a port. Clients must be able to reach virtual servers. Typical options: directly via the network, DNS resolves to the virtual address, or via the NATing device. DNS resolves to an address on the firewall that NATs to the virtual address. The mapping is part of the virtual server's configuration. When a new connection is initiated to a virtual server that is mapped to a pool, various criteria, including the pool's load balancing method, may be used to determine which member to use for that request. The Big IP LTM performs address translation from virtual server addresses to real server addresses. From the client, all the actual servers are seen as single servers, the virtual server. It is important to emphasize that many advanced virtual servers, such as transparent virtual servers, network virtual servers, and wildcard virtual servers, have the same capabilities as standard virtual servers. The only difference is which features are active. When a request is made by a client, the client DNS request is resolved to a virtual address. When a client initiates a request across the internet to a virtual address, the Big IP receives the packet and processes based on the virtual server's definition. The default definition is translate destination address, leave source address alone, choose a pool member based on current status, load balancing, persistence, monitor results. Then the server sends the response via the Big IP. If Big IP does address translation, the response must return through the Big IP so that it can untranslate the addresses. This is commonly done by configuring the server's default route to be the internal floating self-IP address of the Big IP. Alternatively, the Big IP can translate the source address of the packet. Port translation will typically occur. The pool members do not need to be listening on the same port as the virtual server, nor the same port as each other. The request is then sent back to the client through the Big IP. If a monitor marks a pool member as unavailable, the Big IP will direct the traffic to the next available pool member. Clients are unaware that this has occurred. Network managers can be alerted with traps or emails. The packet is sent back to the client from an active pool member through the Big IP system. The LTM is a full proxy architecture and has separate connections on the client and server side of the big IP. This allows a lot of flexibility and function within the product. How full proxy works is the LTM is a server to the client and a client to the server. There is never a direct connection between the actual client and the server. However, the big IP LTM does not change the source address of the packet when in its default configuration. Therefore, programs running on the server intended to capture client information will still function properly and capture the actual address of the client. This is how a basic pool is configured. We will go through this in a future lab. From the Local Traffic tab, click Pools, then Create, then define our name, service, load balancing method, and then add our pool members. Here is how a basic virtual server is configured. We will go through this in future labs as well. Here is how we view statistics. We click on Statistics, Module Statistics, Local Traffic, and select Status Summary. We could also view the pools and virtual servers by themselves. If you ever need to get back to the welcome screen or go back to the setup utility, you can click the F5 ball at the top left. The log information can be used to notify administrators in 4 different ways: by email, pages using postfix, SNMP using traps, centralized syslog servers, updates to the LCD and alarm light. The network map presents a visual hierarchy of the names and status of virtual servers, pools, pool members, and iRoles defined on the system. You can click the name or IP address in the map to open the properties screen of that object. The map shows all objects in context, starting with virtual servers at the top. Okay, let's create some virtual servers and pools now. We will start by creating a pool, then a virtual server, then test for functionality. You may want to take a screenshot of this page so you can follow along in the labs.